We'll be talking about a couple of news items. The first one is from CRP Technology, which are the makers are Windform powder, and they make powder diffusion powders for auto racing and kind of like cutting edge applications mainly. And they have a powder called Windform XT 2.0. It's like a filled powder. And what they're doing is they're recycling it. Now this is really good news because about half the powder people use typically gets thrown away in powder bed fusion. So you can recycle it in the machine. It acts as a support, right? And then you can use it again. Now, how much you can use again depends on a lot of factors, but eventually it's used up, and you can't use it again in the powder bed fusion machine. So you have to find out something else to do with it. And I've always suggested, by the way, if somebody's listening, to use it as filament for material extrusion. But what Windform is doing is just as good, and they're using it for injection molding. So now injection molding companies can buy Windform XT 2.0 IMG injection molding grade, and they can use it for injection molding after it's been used up for 3D printing. So I think that's absolutely fantastic news, and we need to be more sustainable, and it's a wonderful move. Now the other thing that's really surprising actually out of this is they don't add virgin powder for this to work. They remanufactured it in such a way you don't add virgin powder. So often when you recycle something, you have to do, like, for example, 70% of the thing you want to recycle, and then add 30% of the virgin powder to it to make it work, new powder. So in this case, they've managed to make it work without that. So that's I think that's really good news actually. It's really great. And so congrats to the guys at Windform and CRP, and I hope we see a lot more of this. The next news is from IndoMIM. So IndoMIM, which is a large Indian MIM company that is expanding into 3D printing and has done a lot of stuff in 3D printing, offers powder, offers advice, offers services, and is now even more ambitious in this area, and has bought a CMG Technologies. It's a UK-based MIM and sintering and debinding service. What's notable about this is that the CMG, well, first off, it's a UK-based office, so IndoMIM wants to use the presence to expand more into European markets and Europe and England and all that kind of thing. So that's good, right? The other thing is that they use 3D gens printers. So that's bound filament printers to make metal components. So that's, you have regular binder jet, which uses binder jet processes, and then, that's very similar to MIM, right? But the bound metal process, where you're using just a regular kind of a souped up filament 3D printer to make these parts, is another really cheap way to make some parts. Now, of course, you can, with binder jet, you can make some more finer parts, some smaller parts, some really detailed stuff. And this kind of bound metal stuff is really used to, kind of for brackets and stuff like this. But I really love it because we all know the sintering step is hard and the shrinkage and all this kind of stuff. But if you make a library of parts, right, library of like 100 parts or something, you have kind of fairly rough parts. It's super cheap to this filament bound filament method to make these parts. So I really think that could be a really interesting technology. So this also means that IndoMIM, in this acquisition, actually has acquired some more bound metal expertise by the CMG guys, and also the CMG company has its own bound metal filament and make that themselves. So maybe IndoMIM's gonna roll that out as a product that it has. So that's good. Now the other news is from Center Street Technologies, and that's a company that is showcasing its large-scale hybrid solution. That's an 8 by 12 by 24 feet printer that extrudes up to 70 kilos of material an hour as pellets. It's enclosed, right? That's also really notable for one of these materials. So you can use less filled materials, and you could use a broader range of less problems with warps. So that's nice. And it's a hybrid solution. So it uses 3D scanning to make a digital twin and to log the as manufactured digital twin. So it's a nice way, that plus the enclosure is a really nice way to ensure that you get the right part coming out. And that's really good because, well, why do people want these things, right? So one is boat hulls, just for the commercial boating industry. Another, there's a lot of military applications for this, a ton, right? And think things like drones or boats for the military, or sea-based drones or other sea-based craft, submersibles, that kind of thing, torpedoes and missiles and all this kind of thing. A ton of parts, right? And even a country like the United States can't all of a sudden make an extra 1,000 boats a day or something like this, because it's very difficult and it's time consuming, and it'd be difficult to do this without having all the labor and stuff like that. Now they have to make these molds out of wood. They do a lot by hand. And it's also eco unfriendly. But they can't just increase that kind of production in that kind of area. But so these kind of solutions would really, for the U.S. military, really help it produce a lot of things. And on top of that, you could also use this to make a lot of like really large aerospace tooling, and maybe even a lot of outdoor stuff and a lot of other things. So this is it's a good development. There's a couple of companies. Was it Breton Ganesi or something, the Italian one or something like that? The CMS, Delta Systems, the Indian one. Interestingly, I tried to find the Cincinnati Incorporated BAM printer to compare it to this, and I couldn't find it on their website, so maybe that's a little bit of an oversight, or maybe they're less interested in it than they were before. Generally I think this is an interesting space to watch. Also, because I think if this is out there, and if people start thinking of like 70 kilos an hour, we don't know yet how long the milling takes. I usually the printing is like they print the part in 3 hours, and we're going to like mill it for the rest of the week, right? So you have to be a little bit careful. But still, hey, that sounds super duper productive anyway so far. So that's a really good development, I think, and that's going to unlock more things. Some guy's going to say, hey, I make screens for in offices, or I make cubicles. Can I make that with this? People are going to really be kind of thinking about this, be inspired by this. So it's good. And so we'll see what happens. All right. Thank you so much for your time today. I was Joris Peels, and I'm still Joris Peels actually. And you are hopefully a little bit wiser, or know a little bit more about some stuff today. And thank you.